Bienvenidos, Ushamdid, and welcome Anne Arundel Community College learners from the Spring 2023 semester taking the CTS-233 Section 400 Network Programmability course. This is the Cisco Networking Academy's DEVASC 200-901 certification exam preparation course, and in this, our final video tutorial on Lab 357, where we are definitely in the deep end of the Python programming pool at this point. We're going to be taking a look at Part 3, Steps 3 through 7, the final steps in the Create a Python Unit Test Lab. So let's go ahead and pick up on step number 3 of Part 3. And to do that, we need to be in our virtual machine. Again, those of you following along, if you don't have the test data, you're probably not going to see the same results that I'm seeing. But let's go ahead and cover the material here in the virtual machine where we do have the data we need. So it wants us to take a look at the test_JSON_search.py file. Now, this file is actually empty by default, the test.json_search.py, and it simply has a line up here at the top that's going to tell you put your Python code here. So again, they want you to go ahead and type in and put the Python code in here. So we're in our VI session, and you can see fill the Python code in this file. So the first thing we're going to do is we're going to import unit test. Now remember, when I use the import statement with the name of the module just like this, when I say import unit test, what I'm doing is I'm creating a reference to the entire module object. And so if I wanted to access things that are in that library unit test that has all that functionality, I would use the dot notation. In fact, take a look. We imported unit test, and so I want to use this. I'm going to create a subclass here. I can say unittest.TestCase. Again, the reason I say unittest.TestCase is because I imported the entire module object, right? And we gave some deep dive looks at the import statement and what would happen there. So now we have from recursive_JSON search import asterisk. We know what this means. This means import all of the names out of the recursive JSON search file. And so, or I should say Python module. So if we were to take a look at, excuse me, recursive JSON search, what are we pulling in? Well, we would pull our function in, right? Because that's what's in this Python module. It's simply that function. Well, we have the print statement here, but what we're going to get is we're going to get access to the JSON_search function because we're going to need that, right, when we're creating our unit test. So let's go back into JSON search.py. So when I say from recursive JSON import asterisk, what I'm really trying to get access to is JSON search, right? And I can reference it by name. Now, the other way that I could have done this, and let's go ahead and do that, I'll comment that line out. I could have said from recursive JSON search import JSON_search. And this is a better practice. I won't say best practice, but this is a better practice than the asterisk, because who knows what else is inside that recursive JSON search Python module. Again, for the purposes of the lab, we know that there's only one thing in there that we are interested in getting, and that is going to be the JSON search function. All right, well, what about the next import, or I should say the next import line? So we have this line, we've seen this before, from test_data import asterisk. Now, we know what's in there. We know that we would really want key 1, key 2, and data, right? So data is going to be that JSON data that Python's going to treat like a dictionary, and then key 1 and key 2 are just simply keys, issue, I can't remember the exact name, it's issue something for key 1, and then key 2 is like that random search, random string of just stuff, right? But that would be considered a better, more specific practice than importing with the asterisk. We don't know what we're going to get. And again, these import statements here, the better practice ones where I'm very specific and the asterisks are going to achieve the same result, but we want to make sure that we're kind of following some better practices there. So now let's take a look at what we've got in our file below that. So here is our unit test, right? We're going to create a class. I'm calling it, and the reason I'm using this name here is because it's different than what's in the lab to show you that it doesn't have to be, and the lab uses, I think, JSON search test. So I'm using Trav's JSON search test because this is my class, right? I can make it do whatever I want it to do. So I'm going to create a class name here, and then we're going to put unittest.TestCase. Remember, we imported, and you can see that at the very top there, we imported the unit test library, right? So we created a reference to that entire module object, unit test. And so to access the features and functionalities in there, I just simply put in here unit test dot, and then the specific class I'm trying to get access to, which is test case, because now I have access to all of the cool little things that are in test case, right? Like assert true, assert equal. That is how down here I can call this self.assert true, self.assert equal. So again, this might be a little bit confusing. We didn't cover subclasses a ton, but that's what we've done here. And again, that unittest.TestCase, it's designed to be subclassed, right? And so all of the test cases that I have down here in my methods, right? Remember, they look like functions, but they're in a class. So these are methods. They are inextricably linked to the Trav's JSON search test class. They are methods. So what is the self parameter doing in here, right? I want to make sure I clarify this a little bit more. So the self parameter is being used to access the attributes and the functionality and the features of test case, of the test case instance, right? And that's our assert true and our assert false. So when I'm saying self, I'm really referring to unittest.TestCase. Again, part of my overall class right here, but self is kind of saying, okay, unittest.TestCase, and I know there's some stuff in there, so I'm going to say self, referring to that, and give me the assert true method. Give me the assert true method. Give me the assert is instance method. And so that is what self is referring to here. Remember, in the previous examples we saw of some of the basic classes, what did self refer to? It referred to the name of the object that we were creating, like car 1, car 2, car 3, right? And then we had attributes that those cars had. And so it's kind of similar here. Again, we're referring to unittest.TestCase. That is what self refers to. And so then I just say, think of self as representing unittest.TestCase.assert true, unittest.TestCase.assert true, unittest.TestCase.assert is instance, right? And remember, we're familiar with is instance, but this is the asserting, right? We're making these assertions. We're testing these things. And that's what that actually means, right? All right, so I want to make sure we're clear on that because, again, there's always a lot going on in some of the unit testing information that we see here. Okay, so let's take a look at each of these methods. So the first one we define is test_search, and this is how unit test knows that that method is a test. It begins with the word test, and we need to put that in there. Now, we also have an important note here on what we refer to as the doc string. And this is our comment, but it's important that we don't use the pound sign here, right? Like up here where I commented out these two lines of code with the pound sign at the beginning, we don't want to use a pound sign here. And the reason is, if we did, when this unit test runs, it would not print out the comment, right? We want it to print this out to have it make sense, to tell us, hey, key should be found, return list should not be empty. I want to see that when this test runs. So therefore, I need to enclose it in the triple quotes. And whether it's, I typically use just the single quotes, right? So, but we need it in the triple quotes. If I had the pound sign at the beginning of this line, like right here, and then thought that that would get printed up, it will not get printed up. So what are we checking here? Well, we're saying unittest.TestCase assert true. So here's the first assertion that I'm getting ready, that I'm going to be testing. Given an existing key in the JSON object, right? Key 1, so given key 1 in this JSON search, remember we imported that function out of the recursive JSON search module. And so I'm going to provide 2 arguments here. I want to test this. I want to see if I give it, and I think it's issue summary, I think is what the key, I can't remember what the key was. So whatever key 1 was in that file, right? And the data, we're going to send these 2 things and these 2 values into the JSON search object. And I'm checking to see if, given that information, if the testing code can find that key, right? And what should happen here is you can see we've got this empty list. So I'm asserting, is it true that the list is not empty when I search for key 1 in that data? That's really what this is saying, right? That's an empty list. That means not. And in fact, that's probably a typo on my part here. And this is why I usually like spacing. I apologize there. So we want to have a space in there because this stands by itself, is not. So when I run the JSON search function and I provide the key 1 to be searched for in all that data, in the directory object, sorry about that, is it true that it does not return an empty list? In other words, does it find key 1 in the data? We know that it does because key 1 is in there. Now we come down to the second test, right? So our next test, so we test search found, right? So we're trying to see, do we find the key? The next test says search not found. Key should not be found, and I've got a typo here, should return an empty list. So we do, again, unittest.TestCase, that's what self refers to, .assert true. So is this a true statement that when I search using the JSON search function for key 2 in the dictionary object that is all that data that was JSON data originally, but now we're treating it like a Python dictionary, is it true that it is going to return for me or equal an empty list? And again, we should not find key 2. So, and again, given a non-existent key in the JSON object, which is all that data, see if the testing code confirms that no key can be found, right? And so that's what we're looking for. And then the third and final test that we're looking at here is we define our method, right? We're referencing self, which is the object that we've created here, which we're really interested in, unittest.TestCase. .assert is instance. And so what are we checking to see? And again, remember, we get Booleans back. It's either true or false. It's either true or false. And then here we're using the JSON search function, which is in its own little file there called recursive JSON search. And we're searching based on key 1 and the data. But more importantly, we're testing to see if we're testing to see if our function returns a list as it should always do. Remember, the is instance is you give it a data type, and this is going to return something, right? It should return a list. So again, think of it just like in that is instance supplemental video, is what that is returning a list. That is all that is saying, right? Should return a list if working properly. All right, now we're going to go ahead and come all the way down to the bottom here, because one of the things that's important is the last part of the script. We're going to add in the if dunder name equals equal dunder main line. And why would we do that? Again, we do that because there's 2 options to execute this here. And let me show you those options. So I could say Python 3 -m, and really all I have to say is unit test, because unit test actually is smart enough to look for the file or a file name that has test in the name, like test underscore JSON underscore search. So if I say Python 3 minus m unit test and hit enter, you can see that, oh yeah, okay, so we get the output up here, sorry about that. You can see it knows what it's trying, it knows to run that file test underscore JSON, but I think, do I have more than one file that begins with test? I do. I have testdata.py. So here, we run into an issue, right? And I think this is referring to test JSON search, self-assert true, JSON search. Oh yeah, false is not true. So we see the error false is not true. But what do we see? Let's start at the top. Let's take a step back and digress here. So what do we get? We get the empty list. Here are the 3 tests that were run, right? Now you can see fail, test search found, test underscore JSON underscore search, etc. This object key should be found. So the important thing is there's that message I wanted it to be, that I wanted to be printed out. Hey, that key should have been found, but it wasn't, right? And so you get your assertion error down here, false is not true. And then we see ran 3 tests and we had a single failure. Because again, this is really shorthand for 1 test, 2 tests, 3 tests. So 3 tests ran, the second test failed. The second test failed. And again, unit test was smart enough that I didn't have to say Python 3 minus m unit test and then put in here test underscore JSON underscore search .py. So I could run it like this, right? We get the same result, but I'm just showing you it's like 3 different ways to run it. We could run it without saying the name of the file because unit test is smart enough to do it. We could put the name of the file in there. And this is what we would have to do if we wanted to run it directly when, and let me pull test underscore JSON search, when we don't have that Python setup down here that's going to say if dunder name is equal to dunder main, meaning it's being run directly, what are we going to do? Unittest.main. And this is where, again, unit test is smart enough that it knows that if I run this directly, hey, go ahead and start running these tests that are in this module, right? So when I do that, what that allows me to do is to come in here and say, Python 3 test underscore JSON search.py. Again, couldn't do that earlier because we didn't have the if dunder name equal dunder main. Now that that's in there, we run it and you can see we ran it 3 different ways, modified the file, and the results are the same. So it says run the test to see the initial results. We see those results, and now we need to figure out what's going on, right? And so we could use the -v option for verbose output, and they give us, with that -m unit test right here, we could do -v because this is going to give us a little bit additional information up here toward the top. And you can see, we see the empty list, that's what got returned, but then we get all of this information here. So this is what we want to key on right here, the failure, right? I'm looking for my failure. Test underscore search underscore found. Test underscore JSON underscore search dot trav underscore JSON underscore search test. Key should be found. Return list should not be empty. Fail, right? It's an epic fail. So that's where the problem is at. It's something to do in our test. So let's investigate and correct the first error in the recursive JSON. And I'm on step 5 right now, if you're wondering. So let's go back in and we'll go into the recursive JSON search.py. Now, they actually tell us what the error is, but let's understand what the error is. The error is here. And it's that we are creating an empty list inside of the function, JSON underscore search. The reason that this is a problem is because every time that function gets called, and remember, it's being called the first time it runs, the second time it runs the tests, and the third time the unit test runs. The problem is every time it's called, it recreates the list and makes it empty. And so that's the problem that we're having, is that it's called 3 times. It runs the first time, it runs great. But the second time, the second test, the one we're getting the failure on, returns a failure error because this list is recreated, and it's recreated as an empty list. So when we go to run this line down here, return underscore val dot append, and we're appending the temporary key value pair. The first time it runs, there's a key value pair in here, right? I'm sorry, I can't remember the first test is testing, but the second time it runs, it's not going to get put in there, right? Because it's going to be empty. So whatever was in here before is not going to be in there again. And I need to refer back to the tests and remember the order, but that's the problem. So how do we fix it? Well, it's an easy fix. We delete that line from here, and we want to make sure we put it all the way back over here, and we simply put it at the very beginning. And I had commented on this in an earlier video and in earlier videos on lists that this is a common convention you see used, is we create the list empty outside of all of the other code that's going to be running if maybe we're referring to it later. Because here are the semantics behind this. When I put it out here, it's a global variable, meaning it's globally accessible, meaning inside of the function, I can still access this list. And it's not getting overwritten every time the function's called. If it's in the function, it is a local variable. It is not in its local scope, right? The scope of the variable return underscore value, when it was here in the function, means that it is only accessible here in the function. And the bigger problem is every time that the function runs, it recreates return underscore value, and it recreates an empty list. That's a problem. So we put it out here because, again, it's globally accessible because it's in the global scope. When it's inside of a function, it has local scope value. All right. So we moved return value out of the function, recursive underscore JSON.py. We just put it above. Now let's save and let's run the script. And here's where we're just going to be kind of running the script a whole bunch. So I'm going to say clear. Let's run it with that -v, right? Why not get that verbose output? And let's see what happens. So now we see something else up here, right? So it should return a list of working properly. Okay. Now where did we have issues? It was right here. So now the test underscore search underscore found, a key should be found. Return list should not be empty. And here is what is being returned now. Now, instead of being overwritten, we see the list that the RET underscore val is actually appending to. And what is in there? It is a dictionary, an issue summary. That's key 1. And here's the value for that key in this dictionary from curly brace to curly brace. That is our key value pair. Now we see the message. So we run the test again. We see if all of the errors in the script are now fixed, right? And are they? So let's come down here. Now we still have one failure. If I go up a little bit further, right? Where's my fail? So now we've got this failure here. And again, this is all baked in to do this so that we can dig in and figure out what is going on. So key should not be found, should return an empty list, fail, right? Because remember that third and final test, we were testing, right? We were testing the assertion, is it true that JSON underscore search when using key 2 and that data is going to return an empty list? And it says assertion error, false is not true. So what's the problem? We've got to go into the test data file and search for issue summary, which is the value for key 1. So let's do that. So let's go into test underscore data.py, and there it is, right? So key 1 at the very, very top, remember key 1 got set manually here to issue summary. So again, the DNA Center the API would produce the JSON information, the creation of key 1, key 2, and then this data variable, that was manually done for this lab in order for this lab to actually work for us. So key 1 is issue summary. Key 2 is that dumpster fire of a bunch of characters right there, right? So we search for issue summary. Oops, and let's just do issue summary. Let's put it all in there. And so there it is, right? And so that's what we find. And that's the value for key 1. And the lab says you should find it twice, but only once in the JSON data object, which is true. But if you search for the value of key 2, which is that random string, you will only find it at the top where it's defined because it's not in the data JSON object, that dictionary object that we're messing with. So the third test is checking to make sure it's not there. The third test comment states keys should not be found, should return an empty list. However, the function returns a non-empty list. And we saw that. It returned the non-empty list. If I say Q quit, it returned a non-empty list, and we see what it did return. Here's the list that it did return. So that check, that third assertion that we're checking for is when I pass in key 2 and data, I'm asserting, hey, I should get an empty list because we shouldn't match on key 2 because key 2 is not in the dictionary object that's defined by the variable name data, right? Right here. It should return that, but it doesn't because it returns this because it finds key 1. So what do? Well, we can investigate and correct the second error in the recursive search. And how would we do that? So it says to resolve the issue. And again, this is step 7, the final step. We're wrapping up right here. How do we resolve this issue? Well, let's go into recursive JSON search.p, or wait a second. Is that what we want to do? Hold on one second here. Yes, I think that's the file. Yeah, that's the file we're going to do. So we're going to go into recursive search, recursive_JSON search.py. And this is where it's going to get a little bit crazy, right? So it's saying that what we should be doing is wrapping the entire function JSON, or we should wrap with JSON search, we should wrap that as an inner function. Now, that's one way to fix it, and we'll take a look at that in a second. The other way to fix it would be to say that if that's going to return, if we expect that this is going to return an empty list, we could maybe move that method, right? Where could we move that method to? If I pulled up test_JSON. So if I came down here and I'm basically going to say 3YY, and I'm going to come all the way up here to the top right there and say P, and it's going to put it there. And then I'll just come down here and delete those 3 lines, 1, 2, 3, right? If I did that, when that test runs first, right? When that test runs first, oh, wait a second, did I? Oh, here, let me quit out of this. I'm sorry, I think I made a mistake there when I was editing. Key 1, the key 2, I'm sorry, I grabbed the wrong function. So it's this one here, right? That this test here, because again, it should return empty. So what if I said 3 and I could just do DD to delete those because I'm going to do that anyway, and then drop that there. So what if I move it here? Okay, let's rerun the test, and the first method that is there, what's happening? It is still catching that, right? So be aware of that, that even though we put that as the first method, it still fails, right? It still fails because it's running through the other examples as well, and it's checking to see are we getting an empty list back with JSON search key 2 data? When we use key 2 as the key and we look at that object, we don't. And so what we need to do here is we need to refer to this file. So we're on step 7 if you're following along. This is the final step, but it is a monster step. And what they want us to do is to either copy and paste or to type in. And so I've decided I'll go ahead and I'll type in the information here into VS Code for you, right? And I saved it off in that directory where we were working from the CLI. So again, if I was to cat out recursive JSON search, you can see that now it has this new information in here, but I wanted to get it into VS Code so that you can see. Again, I think VS Code is a wonderful learning tool from a visual perspective. So what do? In our recursive JSON search file? Well, we're going to, from test data, we import everything. We know that we could change this, right? We could make it key 1, comma, key 2, comma, and data, and that would work fantastic. And that's probably a better practice. Define JSON search. So what we're doing here now is we have our main JSON search function, but we have a function called inner function that is going to be run every time JSON search gets run. And so you can see the name of the function has changed. The references down here have changed to inner function. I love VS Code. I highlight it one time, it shows up everywhere. And this gives us a little write-up as to what's happening here. And this should solve our problem and get rid of any of the errors that we're seeing, right? All right, so let's go ahead and run this, and let's see if it passes all the tests. And let's get on the command. Let's get on the command line here. And first, let's check and see. We'll do qquit. And yeah, okay, there we go. And then we're going to go ahead and say, we could say Python 3 -m unit test, right? We don't have to say anything other than that because unit test is smart enough. So take a look here. That is what is inside of my list, right? So the list is not empty. All 3 tests ran and all 3 tests finished. You see how quickly that unit testing takes place, and we get okay. So all 3 of the tests that we wanted to have ran, and everything worked fantastic. And so that is going to do it for Lab 357, creating a Python unit test. Again, we reviewed Part 3, Steps 3 through 7, knocked it out of the park, and saw exactly what it is we needed to do in order to get our unit test to not return an error. All right, as always, thank you so much for watching, and I hope to see you in the next video.